Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Sciences, SOS, Master's Degree Programs. Bachelor of Science, BSCG. Skill Enhancement Courses, SEC. BCHS 183 Laboratory Management Skills. Block-1 Laboratory Organization. Unit-1 Introduction to a Laboratory. 1.1 Introduction. You must be familiar with the biology, chemistry and physics laboratories as you get an exposure of these labs during your practical classes in school. Some of you might have worked or still working in laboratories of school. College, universities, are. Organization and management are of similar nature. These may differ in some specific requirements like the presence of wet lab in case of a chemistry lab or dark room for a physics lab or interview room for a psychology lab. You know that the students studying any of the above mentioned labs have to perform a number of experiments or make observations that require a proper laboratory with workbenches, storeroom, preparation room, etc. The laboratory staff should be well equipped in the skills of design, organization, and management of the labs they are working. In order to achieve these skills, the staff should be trained properly. As a staff in the laboratory, you must understand that you are an important member of the team that runs laboratories. So we begin this course by explaining your role as a laboratory staff in managing the laboratory and making you realize its importance. If you understand this, you will be able to do your job better and help students enjoy learning by doing. It is very important to develop a scientific attitude to learn about management of any laboratory. Doing science gives us a set of values and leads to a particular way of life. This is called the scientific way of life or scientific temper. So, in this unit we explain what is meant by scientific way of life and the core values that follow from it. You must adopt these values and the scientific approach both in your profession and in your own life. With the understanding of scientific attitude, you can learn every aspect of your duties. In the next unit, you will learn how a laboratory is organized. Expected learning outcomes. After studying this unit, you should be able to describe the role of a laboratory staff and explain why it is important. Explain what science is and distinguish it from non-science. Describe how scientific knowledge is gained. Explain the importance of laboratories in an investigation and outline the core values of scientific way of life and discuss why these are important in your work. 1.2 Your role in laboratory. We believe that you will be able to do your work as a laboratory staff better if you have some understanding of how a laboratory typically looks like. You would do your work far better if you understand why you are doing it and why it is so important. Understanding why laboratories are needed and why we need to do experiments will help you appreciate and understand how meaningful and important your work is. Before we get into the role of lab staff in a lab, let us explain what is a laboratory. This would help in visualizing the facts that have been discussed in this introductory unit. What is a laboratory? Laboratories are used for practical work or demonstrations that help to explain and support theoretical concepts. A lab could just be a single room or a large building with separate rooms for specific lab work. A laboratory can thus be defined as a room or building fitted out for scientific experiments or experiments concerned with the social science concepts. Science and social science research, teaching, interview sessions for human subjects, activities for effective learning or the manufacture of drugs and chemicals. Schools usually have separate main laboratories for chemistry, physics, and biology. However, the schools and colleges have laboratories belonging to social sciences disciplines also. The focus of this unit is mainly the science laboratories. First of all, you must understand that your work is very important in a laboratory. You are likely to work in any of the science or social science laboratories. The design of mainly the science labs would be discussed in Unit 2. The other labs resemble the science labs in many respects, as you would understand after studying about these in the next unit. You have a vital role to play in the management of these laboratories. With your help, teachers can make learning by doing a very enjoyable and rewarding experience for students. Here we would like to recall a Chinese saying, I hear and I forget. I see and I remember. I do and I understand. So concepts are learned far better if students are allowed to explore, investigate, and do experiments in the laboratory. Working in the laboratory gives you an opportunity to make the learning of a rich and rewarding experience. As a laboratory staff, your job is to help teachers in managing the laboratory in all possible ways. Your major duties will be to ensure daily cleanliness and maintenance of lab, handle, store and issue apparatus, keep the laboratory well stocked, ensure that laboratory equipment and apparatus required for students is clean and in working order, maintain laboratory records and inventory for supplies and reagents, maintain utilities like water, electric and gas supplies in the laboratory, take care of safety measures, brief the students about laboratory safety and protecting their health while working in the lab, carry out minor repairs, assist teachers in setting up demonstration experiments and the overall management of lab, assist students in using apparatus or equipment appropriately, record observations, collect samples, prepare solutions, maintain records, write reports, and keep the lab in a good working condition at all times so that it is an inviting place to work in. This list provides, by and large, the gist of your work. However, we would also like you to understand why your role as a lab staff is important. You must play a positive role in your laboratory and give new ideas for improving its functioning. Working in laboratories can be a very satisfying and rewarding experience if you approach it creatively. Remember, you will be helping in training young minds, some of whom may go on to become scientists or social scientists later. Your work can also be challenging if you can think of better and newer learning activities to enhance the joy of learning science. Thus, you can contribute to make learning of science or social science in the labs an enriching experience for both teachers and students. To understand this point better, you need to understand how you should approach your work in the laboratory. It will help if you understand why you are doing what you are supposed to do in a laboratory. So, if you understand what science is, how it develops, why laboratories are so vital in the development of science, you will be able to appreciate why your role is crucial. This is what you will learn by studying the following sections. 1.3 What is science? Before we explain what science is, it may be better if you first understand what science is not. Science is not a belief system or a faith, superstition or an individual's perception. It is not based on anyone's feelings, views or biases. You must know that science neither deals with supernatural phenomena nor attempts to explain them. To understand what science is, just look at your surroundings. Think of things you see that bring the word science to your mind. These could be the sun or the tube light bulb that provides light for you to see, the food you eat, the plants, trees and birds around you, your mobile or any other gadgets around you, and so on. Science is knowledge of all these and more, in fact, all living and non-living things in the universe. These include stars and galaxies, the sun, earth and the planets and smallest particles in matter, the largest animals, trees and plants on the earth to its tiniest creatures, the rockets and satellites to nuclear reactors, human bodies and human minds that allow you to read and understand these words. Science refers to the body of knowledge about the entire natural world. The origin of the word science is from Latin word scientia, which means knowledge. Scientists focus on the natural world and seek to find answers about natural phenomena. You may ask, what is the natural world? The natural world is what we sense directly or indirectly through our five senses. That is, sight, hearing, touch, smell and taste, or with instruments that enhance our senses. So you have learned that science is a body of knowledge about the entire natural world. But that is only one side of the story. What is it that makes science what it is and different from other branches of knowledge? Science is different from other bodies of knowledge because of the way it is done. Science is also the process through which we gain knowledge about the natural world. Modern science is a systematic process of inquiry by which we try to understand how the natural world works and how it came to be that way. The knowledge gained through this process is the body of knowledge that we call science. So, science is both a body of knowledge and a process using which we learn about the natural world. It is the systematic process of doing science through which the body of knowledge in science is gained and accumulated that makes it different from other bodies of human knowledge such as art, literature, music, religion, etc. You may now like to know, what is the process of doing science? How do we gain this body of knowledge called science? What is the process of inquiry in science that makes it different from other branches of knowledge? We shall discuss this in the following section. Before that, we would like you to check your understanding of what science is and what it is not. 1.3.1 Science as a process of inquiry. We will now explain the process of acquiring scientific knowledge. Scientists explore and investigate the natural world using certain methods of inquiry. These involve a number of operations, both mental and manual. The basic process of scientific inquiry begins by asking questions. These are usually based on observations of the natural world or arise from previous knowledge. We list below the main elements of this process: making observations, asking questions, acquiring previous knowledge, proposing possible answer, framing hypothesis, doing experiments, analyzing experimental results and drawing conclusions, sharing results with scientific community. Note that the number and sequence of operations mentioned in this list can change depending on the subject, area of inquiry. We now briefly explain the various elements of the process of scientific inquiry listed above with the help of examples. Making observations. All of us, whether scientists or not, observe things, events and phenomena. In the past, people observed planets, constellations, eclipses, tides, changes in seasons, plants, animals etc. and decided when to move to better places, when to plant crops, when to celebrate festivals, etc. Even now, farmers often separate the good seeds from bad ones by putting all of them in water. This is based upon the observation that good seeds sink and bad seeds float. In science, we go beyond common observations and experiences and try to understand how and why a phenomenon occurs. Therefore, in science, one needs to be clear about what to observe and how to observe it. You may have heard of Sir C.V. Raman, the first Indian scientist to win the Nobel Prize in Physics. While on a sea voyage from Europe to India in 1921, Raman observed that the color of water in the Mediterranean Sea was deep blue and wondered why it was so. Was it the reflection of the blue sky or was there some other reason? Observations in science may be about natural events, for example, monsoons, change in climate, migration of birds, earthquakes, changes in galaxies, and so on. These could be about properties of materials in order to develop new materials, for example, rocket fuels or nuclear fuels, or for designing new machines. Scientists have to make sure that their observations are not influenced by their sentiments and wishes. Scientific observations are then put in order, classified and recorded. It is important for you to understand that acquiring and employing the skill of systematic, detailed and accurate observation is the first step in any scientific discovery. Asking questions. When we observe any phenomenon such as an eclipse, we are curious to know what causes eclipse, and so we ask a question. Even as a child, you may have asked, why is the sky blue? What is beyond stars and where does universe end? Why do we see a rainbow after it rains? What causes fever? How do images and sound come through television? We can have uncountable questions, isn't it? An unanswered question can prompt a scientific investigation. For example, how can a vaccine be designed for the common cold and cough? Raman observed the color of sea water and asked why it was deep blue. Acquiring previous knowledge. After posing a question, it is important to know if the question has already been answered or not. For an individual scientist, the question she, he answers or the problem she, he solves is often a logical extension of previous work. So it is important to explore previous knowledge which would lead to a more sophisticated understanding of the subject. It also allows us to make decision about the relevance and design of an investigation. Before C.V. Raman, the scientist Lord Rayleigh had proposed that the color of the sea was just a reflection of the color of the sky. The answer to the question came from the knowledge of the previous work on the Phenomenon of scattering of X-rays by A. H. Compton, an American physicist. This led Raman to think about scattering of light by water. That was his possible answer or hypothesis. Proposing possible answer, framing hypothesis. Once an unanswered question is framed, scientists propose a possible answer. A possible answer is termed a hypothesis in science. Hypothesis is generally built to answer a scientific question on the basis of reasoning. It is an intelligent, inspired guess based on observations, reason and previous findings, experience on the subject. For example, if it is observed that bees are attracted to flowers, a hypothesis may be that bees are attracted to flowers for their color, nectar or both. Some more examples of hypothesis are, plants move towards sunlight, snakes possess the ability to hear, a body falls to the ground because it is attracted towards earth, etc. A scientific hypothesis has to be tested and verified by experiments in laboratories or careful observations of natural phenomena in the universe. Doing experiments. Experiments are carried out generally in laboratory or in the field. They are designed to verify, refute or validate a hypothesis. Doing experiments is the most important element in the process of scientific inquiry. That is why an experiment is repeated many times to avoid errors. Scientists have to be certain of the accuracy of experimental results. It should also be possible for other scientists to reproduce and verify experimental results. Remember, laboratories have a central role in the growth of science, and to a good extent some disciplines of social science. To illustrate the importance of experiments, let us continue the story of discovery of Raman effect. By doing experiments on scattering of light by liquids, Raman was able to show conclusively that the color of the sea was the result of the scattering of sunlight by the water molecules. You may be surprised to know that the total cost of the apparatus used by Raman in his experiments was ₹200. Analyzing experimental results and drawing conclusions. Experimental results, observed data have to be examined and analyzed to draw a conclusion. The hypothesis may be accepted or rejected. If needed, it may be modified and again put to test. Analysis of Raman's experimental results led to many applications. With the invention of the laser, the Raman effect has proved to be a very useful tool for scientists to analyze the structure of materials. Sharing results with the community, scientific reporting. An experiment or its analysis alone has no value unless it is shared with other scientists and society at large. It is accompanied by a written report with an explanation, verification and a hypothesis. It is important that every detail of how an experiment was conducted is described in the report. When reporting experimental results, accuracy, honesty and clarity of presentation are essential. Scientific and social science-related results and explanations are always communicated by publishing in journals or presenting in conferences, seminars. If a new experiment or finding proves the earlier results or explanations to be incorrect or incomplete, the earlier explanations are revised or may even be discarded. Researchers do not stick to any explanation or theory unless these are tested by experiments and found to be valid, reported and accepted. So we find that beginning with the simple observation, the deep blue color of Mediterranean Sea led to an important discovery known as Raman effect, for which Sir C.V. Raman was awarded the Nobel Prize in Physics in 1930. While we teach or learn science in schools and colleges, it may seem to most of us like a collection of facts listed in textbooks. This is not entirely so. You have learned that science is also a process of inquiry and discovery. It helps us to make sense of these facts to arrive at an understanding of the natural world and how it works. We hope that from the discussion so far, you have got some understanding of how scientific knowledge develops. You may now like to revise the process of scientific inquiry before studying the next section. 1.3.2 Features of Science. You have now learned that science is a body of knowledge about the natural world and also the process of acquiring that knowledge. It is gained through a process of inquiry that involves testing hypotheses on the basis of experiments and observations. Due to this process of inquiry, science has many features that you need to understand so that you can help in improving The teaching learning of science in your laboratories. Science is ongoing and ever growing. Science develops continuously. As newer tools of inquiry develop, observations can be refined and experiments repeated. New questions are thrown up and new answers come up. As an example, let us take the story of discovery of the atoms. Inner structure. After the discovery of electron in 1897, it was thought that atoms were like a plum pudding of positive charges with electrons lying in it like raisins, see Fig. 1.2a. Experiments done about 10 years later led to this picture of an atom. That most of the mass and positive charge of an atom is concentrated in the center in a very small fraction of its volume known as its nucleus. Electrons move around it. Fig. 1.2b. In the last 100 years or so, refined tools have led us to refine our understanding of the atom's inner structure. The current understanding is that the nucleus is made up of protons and neutrons, which are themselves made up of very tiny elementary particles called quarks. The electrons are distributed as charge clouds of various shapes around the nucleus. The search continues. Similarly, our understanding of the universe has entirely changed in the last 500 years or so. It was believed in the ancient times that the Earth was at the center of the universe. Then about 500 years ago, on the basis of observations in astronomy, a model of the universe with the sun at its center was developed. Now the use of sophisticated telescopes has led to the understanding that the universe has no center and no boundaries. So, old models and conclusions change continuously in science as newer data and results come in. Therefore, science is always revisited, revised, and/or improved. Each new observation, experimental result can throw up another set of new questions to be investigated. This brings us to another feature of science. Science is open to change. Scientific ideas are accepted only after these have been tested through experiments. Therefore, science is open to change. Also, science is not dogmatic. If earlier ideas are proved to be wrong through careful experiments, science does not insist on standing by them. There is no notion in science that cannot be tested or challenged, provided there is evidence to do so. In that sense, no scientist can claim that he has absolute knowledge of how nature works and cannot be questioned. Science is, therefore, self-correcting. Science is objective. You have learned that the results of science can be repeated and verified by anyone anywhere if proper laboratories are available to be accepted as science. All ideas must be tested and verified through observations and experiments. In that sense, it does not depend on the biases or opinions of some higher authority or select groups of individuals. No high authority or individual can save a theory in science if it is disproved by experiments or observations. Modern science is a global human effort. People all over the world participate as individuals, in groups in the process of creating scientific and other related knowledge. And you can too, in the laboratories that you work in. So far you have learned that science poses questions, generates ideas and constitutes a way of thinking. It involves observation and insight as well as reasoning and intuition. Science relies on testing ideas to see if the expected answers are correct. Ideas that are not testable or falsifiable scientifically now, or in future, are not considered science. So, you have now developed an understanding of science as a body of knowledge, as a process of inquiry, as a human effort that has certain characteristic features. You can try applying this understanding to another science lab or a social science lab wherever you might be working. The process of scientific inquiry and its features give a set of values and a way of life to those who follow it or who are involved in teaching learning of science. We now briefly discuss this aspect of science. 1.4 Science as a way of life. The features that characterize science give rise to a certain outlook or a way of life, an approach towards life of an individual or of society, and a set of values. Due to the reliance on testing and evidence for accepting any idea in science, this way of life does not adhere to biases. Science gives us an outlook which makes us think and act in a logical manner, reject superstitions, prejudices, and question preconceived notions and injustice. It also gives us integrity in the pursuit of better understanding. You have learned that while doing science, we have to be objective. Otherwise, we cannot succeed in our investigations. If we are objective in our laboratories, why would we not be so in our daily lives? Doing experiments in a laboratory requires a lot of discipline, perseverance, and patience, which becomes a habit of professionals. As you now know, scientific truths are accepted after a lot of scrutiny and discussion. Therefore, tolerance for difference of views and approaches is an accepted way of life in science. The acceptance of the right to question and be questioned are part of a scientific way of life. The term scientific temper was first used for this way of life and set of values in India by the first Prime Minister of India, Pandit Jawaharlal Nehru. Let us quote him from his book entitled The Discovery of India. What is needed is the scientific approach, the adventurous and yet critical temper of science, the search for truth and new knowledge, the refusal to accept anything without testing and trial, the capacity to change previous conclusions in the face of new evidence, the reliance on observed fact and not on preconceived theory, the hard discipline of the mind. All this is necessary not merely for the application of science but for life itself and the solution of its many problems. Science is thus a way of life, a process of thinking, a method of acting in associating with our fellow men. It is important to note that in ancient Indian texts we find that intellectual debates were dialogue, questioning, logical arguments, reasoning and discussions were a part of life in those times and were encouraged. In this regard, the names of illustrious women philosophers Gargi and Maitreyi are well known. The Buddhist tradition and other traditions in Indian philosophy, such as the Lokayata, Samkhya school, the Nyaya Vaisesika schools and early Jain scholars emphasized reasoning, logic and the spirit of inquiry. You may now like to take a break and think about what you have studied in this section. 1.5 Approach to your work as a laboratory staff. So far, you have learnt about what working in a science laboratory means, what science is, how it develops and what the scientific way of life is. You know that this way of life prevents us from being biased or adopting misguided beliefs. A scientific way of life is not limited to science laboratories or consuming available information. The same set of guiding principles can be followed while working in the other science and social science laboratories. These principles influence the way we live our lives and approach our work. Therefore, in the last section of this unit we briefly outlined the approach you should adopt towards your work as a laboratory staff. Working in a laboratory is actually very fascinating and engrossing activity. But you need to work seriously, attentively, and with patience and perseverance. You must keep in mind that laboratory work is not just some mindless manual work. You need to apply your mind and work very carefully and systematically. You must avoid chatting while doing any type of job in a lab. You may like to adopt the values described in Sec. 1.4 and try to be objective, open-minded, patient, tolerant and willing to help while dealing with students. Never scold students if they make mistakes. This can dishearten them. You, too, may make mistakes during your work. The important thing is to learn from your mistakes, not repeat them and try to improve your work. You should be serious about your work and attentive. Always be encouraging and positive in your attitude. Your interaction with students, your colleagues and teachers present in the lab has to be courteous and polite. There is no space for anger in individuals. Working in a laboratory as an angry mind is prone to illogical thinking and errors. Remember, you are a professional in a laboratory and your work as laboratory staff is dignified and important. No laboratory can function without laboratory staff. You should not think of it as a mechanical manual job. You have learned that you can also think up new ideas and help in improving the experiments. You should understand that the work of laboratory technicians is equally dignified and adopt the value of dignity of labor. You should do your work with utmost honesty and integrity. Hard work and sincerity of purpose will go a long way in making your work satisfying for you. You should try out new ideas and enrich existing experiments. Never give up when faced with any difficulty. Take help and do not hesitate to ask questions. If you feel that logic and reason are being ignored, This is what you have learnt in this unit about science and working in science labs. Through your efforts, you can help in making teaching learning of a truly rewarding and enjoyable experience for your students. Remember, you can nurture a scientific attitude in your students from a very young age so that they keenly practice it throughout life. That is why your work in laboratories is truly important. You too will undergo similar training as a student in this program, and we hope that these values, way of life and attitude will help you to learn better. Let us now summarize what you have learnt in this unit. 1.6 Summary. Science is a body of knowledge and a process of inquiry about the natural world. It is developed by scientists through a process of questioning, observation, building hypotheses, testing of ideas by doing experiments, and explaining experimental results. Observation and experiments are the main elements of the process of scientific inquiry. Ideas that are not testable through observations or experiments now or in future are not considered science. Accepted scientific knowledge is considered to be reliable because it has been subjected to strict testing through carefully done experiments. But as new evidence is acquired through newer experiments and new knowledge is gained, the older ideas can be revised. The process of creating scientific knowledge gives science certain characteristics that make it different from other branches of knowledge. These are mainly that science is open to change, not dogmatic, self-correcting and objective. Science poses questions, generates ideas and constitutes a way of thinking. It gives us a way of life that does not accept anything without testing, makes us change our notions in the face of evidence, discipline of the mind. It gives us a set of values that emphasize on truth, honesty, integrity, patience, tolerance for difference of opinion, discipline and dignity of labor. As a laboratory staff, you should approach your work by being objective, open-minded, patient, courteous, polite, tolerant and willing to help. Students, you must be willing to learn from your mistakes and do your work sincerely and honestly. Thank you for watching. We will see you in the next video with the next chapter.